Hey there, in this video I'd like to touch on the REST API design, which is an important issue that many people miss. I realized that many people in the industry are writing random REST APIs. This shouldn't happen. It's actually not that difficult. I'm a computer engineer developing software and hardware professionally since 2018. My area of expertise is designing software, drawing its architecture, and playing an active role in developing and deploying. Over the years, I have developed dozens of mobile applications, websites, and web services. Now, I will explain to you one of the important subjects called REST API designing. Let's get started with the design. So right now you can see in the screen there are like two different parts, methods and the principles. So there are 6 different principles. We are going to go over every one of them detailedly, and there are 5 different methods, but we are going to start from the methods. And you can see in the right side there are some steps like simple and fine-grained, pagination and filtering, ordering. These are the best practices in the REST APIs, okay? We are gonna go over them in the next minutes. So many people are trying to be simple when coding REST APIs. They don't think ahead. They write a new function for each operation and even use the wrong method most of the time. They don't even know which status code to return, etc. I can count lots of problems. In this video, I'll talk about the standards that we have to comply with while designing a REST API and give practical examples. Let's talk about the methods first. Okay, we have total of 5 methods, but I'm sure many of you have only used 2 of them so far, get and post. But this shouldn't be that much. Now let's examine in detail which method and how we should use it. First method, get. The get method should be used when retrieving a data. It should never ever be used while updating or deleting a data. A successful GET request expected to return 200 HTTP status code. But I'll give you some simple note. Although the GET method is not very common, it can also be used to check whether its request is authenticated. Mostly post method preferred to check if the request is authenticated or not, but this is not a very common usage style. Just let you know about this. In this case you can return the 204 HTTP status code, but let me show you in the screen right now an example usage of the get methods in Java Spring Boot. As you can see, there is a get mapping annotation using as you can see the path, of course. Here you can check it more in detail, okay? The second method is post. The post method should be used when performing a data insertion operation to the database or somewhere else. You should never ever use it while updating a data. There is another method that does this job. After a successful post request, 201 HTTP status code returns are expected. An example usage, as you can see here in the screen, of the post method in Java Spring Boot. There is an annotation for the post method, as you can see, at post mapping, and you can see the path, of course. You can check it detailedly in the description below, okay? There is a link to my Medium post about this. You can check and you can get the codes if you want. So another method is put. The put method should be used if you want to update an entire object, okay? For example, suppose a book object has a name, number of pages, and author name information, okay? You shouldn't use this method if you only want to update the page count of this book object. This method should only be used if and only if all information is to be updated. A successful put request expected to return 200 HTTP status code. In the screen right now you can see an example usage of the put method in Java Spring Boot, and you can see the annotation again, put mapping, and you can see the path. The next method is called patch. The patch method should be used when updating one or more properties of an object. To give an example on the book object, as we mentioned earlier, if you want to update only the name of that book, you should use patch. But if you want to update whole book, you gotta use put. A successful patch request is expected to return 200 HTTP status code. You can see the annotation again in the screen, patch mapping, and you can see the path, of course. And the last method is delete. As the name suggests, the delete method should be used when deleting a data. A successful delete request is expected to return 200 or 204 HTTP status code. 204 also known as no content. As you can see in the screen right now, you can easily see the Java Spring Boot annotation, delete, mapping, and you can see the path. Right now you learned all the methods, general meanings, and how to use them. But there is one important thing I would like to add. While preparing the endpoints, we shouldn't send the ID or primary key value in the request body. Instead, we need to place it in the URL correctly, okay? For example, as you can see in the screen right now, to list the books in the database, you gotta use books endpoint. To review a book, you gotta use books/1. To add a book, you gotta send a post request to the books. To update the book in the database, you gotta send a put request to the books/1. The one is right now in the URL is ID. So if you want to review a book by a user in the database, you gotta check user/1, which is user ID, /books/1, which is book ID. Now that we have examined the examples, we can move on to the principles. Okay, when designing a REST API, we must strictly adhere to 6 principles in total. We must grasp these principles well and integrate them while coding. First principle is cacheable. We should be able to measure whether an endpoint is cacheable on the server side, because it will cost time and money to retrieve the data that doesn't change frequently from a continuous source. The client doesn't like to wait too long. Therefore, data should be presented to them quickly via the cache service like Elasticache Redis. Right now you can see in the screen there is an example code of using the cache service in JavaScript Spring Boot. There is an annotation called Cachable, but it's not limited to that. To put a cacheable books, it doesn't work like this. You gotta add some more configuration. You can check my GitHub repo in the repository and see the cache configurations. The second principle is code on demand. Among the principles, all the other 6 principles, this is the only one that is optionally applicable. It's not mandatory to apply. In the responses returned by the server on the client, there may be an executable code that client can use directly from the response body. For example, we can say JavaScript codes from the server. The benefit of this is to improve the flexibility of the client side, because the server can decide from case to case what the client will do. In this way, the client doesn't always to use if-else statements, and we produce a cleaner code. The third principle is stateless. When a request is sent from the client to the server, it must be completely stateless. If a request can be sent depending on any component on the client side, this is unfortunately not correct. The API cannot be scaled easily in that case. At the same time, when sending a request and when the server receives the request, it shouldn't need another request or another function to read the information in that request that client sent. But I'd like to add an important note that the session should always be time-based on the client side. The server should only use the session to authenticate the request and not store the session, okay? Server never store the session. Always client should store the session. This is a really important thing. The fourth principle is layered system. When sending a request, the client cannot know exactly whether it's sending a request to the endpoint or to a proxy. Never knows. In this case, therefore, you should have the opportunity to add more than one layer between the server and the client. These layers can be used more than one purpose. For example, you can put a load balancer, you can put a security policy layer or some other things. You can just make it more scalable, you know. The fifth principle is client server. The client and the server must be completely separate from each other. Any API query should be able to work correctly on different platforms, different places, different machines, completely independently. An update on the client shouldn't affect the server side because it doesn't make sense, you know. You can't scale easily. REST APIs designed by highly scalable architectures, you know. The sixth principle, and this is the most complex one, okay, most of the people are just like confusing when they hear this principle, is called uniform interface. The uniform interface has a total 4 different features, okay. Thanks to these features, the interface is separated from the implementation. As a result, a more scalable API is created. Okay, so I'm gonna give you an example, and this example is gonna make you understand what is uniform interface actually. Because as I told you before, there are 4 different features in the uniform interface. We are gonna go over detail a little bit more, but let me give you the example of the uniform interface in the real life. Okay, the best example of uniform interface is internet browsers like Google Chrome, like Microsoft Edge, etc. Yeah, like you use a single browser to read news, browse social networks, or chat to your friends in the social media, right? Here's the best example of a uniform interface where you can do all the work and at the same time develop all the work independently of each other, right? When you develop a news website, you don't break something on the social medias, right? If you have all the internet. Think about it. Everything is separated. A uniform interface allows the conversation between the client and the server to always be in one language. In this way, development become more standardized and proceed in a logical way. For example, take a look at the image in the screen right now. As you can see, this is showing the 4 different features of the uniform interface. The first one is identification of resources. You gotta identify all the resources easily and understandable, okay? It gotta make sense. As you can see in the screen right now, the URL, there is a books is pluralized. I'm gonna go over it in that thing a little bit more, but here you can see. The second thing is manipulation of resources through representations. You gotta represent the data, the resource, with the standard ways, like JSON, like XML, or any other representation type. The third feature is self-descriptive messages. So here you can see HTTP GET, post, or any other method. You can understand, every web developer knows what they do, or they already self-descriptive, you know. When you send the HTTP GET request, you expect, I'm not adding any data, I'm not inserting any data, you're expecting to get some data, right? To retrieve some data. Or if you're using post, you don't retrieve any data from the database, you just insert a new data. That's what I mean. Also, the fourth feature is HATOS, also known as hypermedia as the engine of application status. It's a little bit complex and is a little bit confusable because there are so many parts of the hypermedia APIs, but I'm gonna show you an example of how to implement a HATOS because most of us actually implemented before. If you write a pagination service in your career, in your previous career, you probably used HATOS. So as you can see right now in the screen, you're seeing a code, right? Let's check a little longer on the most complex part, HATOS. When sending a request to the server, client can send it as headers, query parameters, URLs, or body contents, right? At the same time, the server can respond to this request with the header, which is response headers, with the response body or response codes like the HTTP status codes, right? So in the screen right now, you're seeing a simple response body, but there is something really important in that JSON. It's called links, and it has href, relation, and the type of that link. As you can see right now, the server helped the client side how to make a request to some link related with the object of JSON. This is how the HATOS works. There are some other type of using the HATOS. You can check everything in the Medium content in the description below, okay? So let's go to the best practices. Every REST API should have definitely 7 common features, which I will list right now in the screen. You're gonna see it. We can say that an API with these features has been designed successfully. Every REST API should be simple and fine-grained. Always keep your endpoints simple and clear. It can mimic your system's underlying application domain or database architecture. The client doesn't want to open the documents when trying to request an endpoint. It should be easily understandable and imaginable, you know? They can easily send requests according to standards. Don't run away from standards. Second, the pagination. Endpoints that need to return a lot of results should use pagination. But it doesn't just end here. When using pagination, the body content must have first, last, next, and preview values, and the client should be able to use them easily. Another practice is, of course, filtering and ordering. Endpoints that return multiple data should have filtering and ordering features. At the same time, it should be possible to intervene in which fields the data to be returned will have, because the returned data should always the data that the client needs. Otherwise, the bandwidth will swell and costs will be incurred. The next practice is resource naming. You should definitely group your data well, because when naming your endpoints, you will prepare them according to the names of these data. Remember that the REST APIs are made for consumers, not for the producers. Resource naming and URL structure should be clear. Always design for your clients, not your data. But I would like to make a short and important note. Always use pluralization in your URLs. It will be more accurate to use /books instead of book for clarity. The next practice is versioning. The prospect of making drastic API changes in the long run is not a good prospect. But sometimes you can't see it and some drastic changes are necessary, right? In this case, you should definitely consider adding versions to your API endpoints. There are 3 different versioning types in total: URL versioning, headers versioning, query param versioning, as you can see in the screen right now. The next practice is caching. If your endpoints frequently return the same data, it will make sense to cache them. We've already talked about this in the principles, but at this point it doesn't end with just caching. At the same time, you should inform the client about the cache details. It will be best to give this information with response headers. Most of the people are doing this. It's very useful for client to set the headers, set the response headers such as cache control, expires, pragma, last modify, etc. Okay, the last practice is security. It's time for a must-have feature for a REST API: security. When setting a security for an endpoint, we need to pay attention to 5 different items in total. Okay, these 5 items is really important. First, authorization and authentication. While preparing your endpoints, you need to choose whether that endpoint will be accessible to everyone. In this case, only authorized users can access that endpoint. For example, we want everyone to be able to see the books, right? That's correct. Everyone can see the books in a library. But who wants everyone to be able to delete the books in the database? Do you really want that? Second, course. Implementing the course feature on endpoints is very simple. You just need to add values like access control allow origin or access control allow credentials in the HTTP header. When course is enabled, the clients that you have given permission to the relevant endpoints can send requests. This could be from other sources as well. It's up to you. It's just like you're giving some permissions using some domains, using some IPs, or using the asterisks, you know. Okay, third is TLS. All your connections must use SSL for confidentiality reasons. But OAuth2 requires the authorization server and access token credentials to use TLS, just let you know. The fourth one is idempotence. Each endpoint should be able to give the same response to the same request every time. When the same request is sent to the same endpoint twice, scalability and improvability problems may arise if different responses are received. Inconsistencies are not tolerated when implementing a correct REST API. The fifth one and the last one is input validation. Always make sure to validate all the input values in the sent requests, because you avoid potential SQL or NoSQL injections and protect your database. In particular, don't be afraid to limit the size of the messages that can be sent. When an error occurs, only show the error to the client. Don't report lines of the code. Okay? Now you'll be able to design a REST API yourself and make it secure. Today, most of the professional frameworks offer you all the things I told you here in a way that makes it easier for everyone. Therefore, it may be useful for you to practice using these frameworks at the beginning stage. For example, PHP Laravel, Java Spring Boot, and other mostly known frameworks helps you designing a correct RESTful API. Thank you for watching this video, and if you have any other questions, you can ask me in the comment section, and if you want to check more about this, you can go to the description and click the link about the Medium post. If you like the video, don't forget to smash the like button and subscribe my channel if it's possible for you. And I'm trying to share my experience on the software industry, and I just want to contribute a little bit more to this industry, and I would love to be a little bit more helpful for the industry actually. Thank you for watching again, and see you in the next video.